Okay, yeah, people may trickle in, but yeah, Aura, why don't you
Sure. So
take the whole hour.
I was at the US Semantic Technology Symposium last week. It was held at Michigan State University, East Lansing, Michigan. And I gave a keynote there, so Alan just asked me if I could kind of reprise that here. So that's what I'm going to be doing. Let me share my screen.
Did you collaborate with Peter Winstanley on that too, Aura?
I did not. Nope.
Okay, I know. I think Peter presented there as well.
I was unfortunately I was there only a day and a half, so I didn't catch everything. Can you guys see my screen now?
Yep.
Yes.
Yes.
Okay, so let me just get right on it. So I wanted to give a talk that was kind of aspirational. Some people might think I'm venting my frustrations, but really it is an aspirational talk. When I gave a keynote talk at the Knowledge Graph conference earlier this year, I talked a lot about the sort of the issues that I see in the what I can only call the data industry. And so this kind of this seems to be sort of a recurring theme in my life. I see these things, I vent about them. I remind people that the semantic web technologies actually are rather mature and have addressed many of these issues that I see. So, I pulled up some, talks that I've given in the past, sort of random sampling, and it seems that I keep talking about the same stuff. Well, basically, this is what I'm going to do now. So I'm going to talk a little bit about the issues, then a little bit about solutions, and then there's something that I like to think is a call to action, and that's it. So
you forgot the back loop, Aura, too, with your frustration in
it. Yeah, I mean that was a linear thing, but obviously, the full
now we go back to the issues.
The full thing is not linear. Yeah, exactly. Anyway, so issue number one is semantics or rather lack thereof. So, and when I look at kind of what people are doing with data, so obviously the old approach was that we built applications. Those applications kind of understood the semantics of their data, but it was kind of a closely held secret in a way, and they acted as guardians of this data. And the only way to get to the data was through a particular application or system, and that obviously leads to the silos that we are now fighting. It was difficult to move data, it was difficult to share data. And now the so-called modern approach, and modern in quotations, because I don't think we've made enough progress. So the physical data, the actual bits, they move better, but semantics does not move. And so it's like, I find that most people don't actually know what semantic means. And then there is this confusion that people have between kind of their own interpretation of what the data means versus kind of the formal semantics that data might have. And I'll just illustrate that a little bit using JSON as an example. So people say things like JSON is easy to understand, and the answer obviously is no, it isn't. You just think it's easy to understand. And that's because you place your own interpretation on what you see. So then people say things like, my data model is JSON. And that's even worse. First of all, because it is not a data model, and JSON has no semantics whatsoever. And then finally, they say, my data is just JSON. And I absolutely will promise you, your data is never, ever just JSON. You always impose your your external semantics on it. And in fact, somebody just I think yesterday or day before pointed out, well, what about JSON LD? And I said, well, JSON LD is not JSON, because JSON LD is JSON plus this external semantics imposed on it, which kind of proves my point. And so what's happening with data modeling today? I don't see it as a big priority for people, although there have been some, positive kind of developments lately. People have started talking about the importance of data modeling and teaching data modeling and understanding that data modeling is really something that serves business rather than technology. But historically, so data models have been sort of a necessary evil in some sense. You have to have something so that you can actually write code. And then, yeah, we don't teach that enough. So then people will say, well, what about APIs? Surely APIs will solve our problem. So no, they don't. And the reason is that every API essentially is like a new data model. Somebody just pointed out it's actually two data models. It's the data model for data going in and the data model for the data coming out, and which may not be the same. And every one of these is like a new language. And so the more APIs you have, the more languages you have. So in fact, you are here. This, of course, is the Tower of Babel. Current situation is everybody's talking, nobody's understanding. So, we have sort of like situation like this. We have systems and they move data, and every system sort of not even redefining the semantics, but basically like re-articulating the semantics. And whether they do that correctly or not is a separate question. But mostly I think it's just stupid because it's like a lot of work. I mean, I see this. I see people doing this all the time. And so this is not what I want. I want this. I want data to move with semantics, or semantics move with data, so that so now you ask, why would I do that? So the baseline, the absolute low bar here is that, well, it's less error prone because there's a now smaller likelihood that you misunderstand what the data was about. All right, so enough about semantics. So then then there's the issue of we don't just have RDF graphs. Now we have other kinds of graphs that have shown up. And so I think I've met a lot of people who basically come to me and claim that, well, Semantic Web is kind of dead now. We don't need any of that because we have these labeled property graphs. And I think that labeled property graphs, they're not really a sort of a straight replacement for RDF by any means. I think labeled property graphs, you should really view them as being, well, they are a data structure. They're a literal data structure. And we write code to manipulate this data structure. And in a way, there's nothing wrong with this. This is what we have been doing since the advent of computer science and software development. We write code that manipulates data structures, and this is fine. You have a graph database that makes it easier for you to manipulate these large data structures. That's fine, but that's not what RDF is, or the semantic web stack as a whole. There, you're building logical models or representations of your data. And I think that if you're using RDF as just a data structure, you're kind of doing it wrong. Okay, but we have issues. So first of all, I have to note that RDF's design, and of course it's been criticized a lot, but the design was very, very deliberate with respect to knowledge representation. it wasn't necessarily so deliberate or even fully successful when it comes to the software abstractions for RDF. Our RDF is kind of difficult to program with, so I'm just illustrating it with this. You know, I'm basically modifying the elements of a single container in an RDF graph. And I like Python, mind you, but this is just horror. And mind you, this is not all the code that I had to write to do this. So so I think that the triples as the sort of decomposition of an RDF graph are a very, very low level abstraction, and it's a little bit like you were programming with assembly language. There's a reason why we don't do that so much anymore, if at all. We need higher level abstractions for programming. For composite data types are kind of cumbersome in RDF. There's a reason why they are the way they are, but they don't make it easy from the software development standpoint. And then there is like mounting evidence that developers really don't want to have anything to do with Sparkle. I don't necessarily understand why this is, but this just seems to be the case. Now, labeled property graphs, on the other hand, tend to be kind of close to the developer mindset, and have. I'm not necessarily sure they're good programming abstractions, but they're better than what we have for RDF. And then my absolute favorite here, labeled property graph query languages support pathfinding. So when you traverse a graph as a result of your query, you can find out afterwards what was the path that you took, which to me seems like an essential use case for graphs. And you can't do that in Sparkle, which just shows that Sparkle kind of falls a little short on what we would expect from a graph query language. And one thing I wanted to mention here, although I'm not going to talk about it, is that user interfaces are a challenge for both kinds of graphs. I mean, we have incredibly expressive data, and the user interface expressiveness simply hasn't caught up. All right, so I am from the Amazon Neptune team, so I have to mention Amazon Neptune a little bit. So it's a fully managed cloud database. And we support both RDF and labeled property graphs. So we support Sparkle, Gremlin, and OpenCipher. And customers can choose. So that's the good thing. The bad thing is they have to choose. Mm-hmm. And so this is oftentimes they choose wrong. And then it's hard to walk back that decision. And that's frustrating for us because we would like a better experience for customers. So we have kind of this rift now between RDF and labeled property graphs. It's confusing to the users. It should not matter, but it does. And I think it hurts the whole industry and community. I'm not talking only about from the Neptune standpoint or about our customers. I think that this is sort of a broader issue. Mm-hmm. So do we have any solutions for any of this? So we have this project that we're working on called OneGraph, where we are basically defining a unifying meta model that will encompass both property graphs and RDF. And this is not easy. There are some very tricky details in this. And RDF star, which is work that is now starting in earnest at W3C, is a significant step in the direction of sort of bringing RDF and property graphs closer to one another. But it's, as we as we understand RDF star today, and of course this everything may still change, it's not enough. Now the real sticking point is that we don't necessarily want to break RDF semantics, because it took us a very long time to get those right. And so so that's the challenge. But the good news is, if we succeed, and I'm 100% convinced that we will eventually, we can kind of see benefits on both sides of this rift. We get to use all the good features of the semantic web stack on the property graph side. Strong identifiers being one, strong global unique identifiers being one of those. No more people complaining that RDF doesn't have edge properties. And my absolute favorite, I can then run Gremlin over RDF, which means that I will solve this pathfinding problem that I mentioned earlier. Okay, so the RDF not having edge properties. So the caveat here is that we need a semantic theory for what it means for making a statement about another RDF statement. So of course the original RDF spec introduced this mechanism that we call reification. It's, I believe, the most misunderstood part of the original spec. People took it too literally. But essentially what it does is that it lets you, instead of making an actual statement about something, you basically make a model of the statement, and then you make statements about that model. So now you can say things like, Steve believes that the moon is made of cheese, without actually saying that the moon is made of cheese. So fun story, in the original RDF working group, when we were working on this, I pointed out that when we create the semantic theory for this, we're going to have to step outside whatever sort of system of logic, simple propositional logic at the time we're in, and we're going to be in some system of modal logic. And as soon as I said that, nobody wanted to touch it. And thus, reification today in RDF has no semantic theory. And so so why do we need this? Well, I'd like to be actually able to use this mechanism, and the mechanism that RDF star is going to give us that makes it easy to make statements about other statements. I'd like to use that in my ontologies, in my models. But for that, we need not only a sort of a modeling vocabulary for that, but we also need to understand what it means when you make statements about statements. Of course, the real issue in sort of with this rift is probably this. Is that the graphs really simply are not the same, like I already said. RDF and OWL, when you build graphs, they're more like a logical model, logical representation of your data, whereas the LPGs are a very concrete, literal data structure. And so we just last week we had a paper published in the Semantic Web journal that talks about this project. No final answers yet in that paper, but it's more sort of like a catalog of challenges. And then those who maybe you all caught up with this already, but sort of the name of the project, One Graph, is obviously a Tolkien reference. One graph to rule them all.
Rule them all. Yeah.
My boss thought it's way too arrogant, but we went with that anyway. So I think what we really need as sort of a solution for all of the things that I've talked about so far is some kind of a unifying language for data, so that we can talk about data and we can represent data. And we just need a good mechanism to define and communicate semantics. Now, it's important in this context that I say that syntax really does not matter. People always tell me that syntax matters. It really doesn't. We've solved that problem and we can kind of forget about that. I think RDF and OWL are the best candidate for a language like this. I would be happy to welcome a better solution, but somehow in the 20 plus years, the last 20 plus years, a better, more viable candidate has not shown up. So the semantic web technologies, they are mature and they're well thought out, and I think that we can really work with them and start solving some problems. Okay, so obviously this is a talk about the semantic web. So here comes my sort of call to action now. And because this is about semantic web, I have to kind of reiterate, why do I find semantic web technologies attractive? I found them attractive when we created them, and I still find them attractive. And so here's my short list. So first of all, we can have self-describing data with accessible semantics. The semantics will now, you will have access to the definitions of semantics, and you can actually have the semantics kind of travel with the data. And it's important that we start thinking that when somebody asks for access to some data, if you only give them the physical bits, you're kind of doing them a disservice. You have to also tell them what those bits mean. And so for this I use this kind of a thought experiment, and maybe some of you have heard me do this before, but sort of, let's say I have some data and I put it in an Excel spreadsheet. Why Excel? Well, because Excel is the dominant data management tool of our time. No kidding. And so I'll put it in it's now in nice columns, and I try to give descriptive names to those columns. Okay, so now it's in an Excel spreadsheet. I put that on a USB stick and I bury it to the ground. And then 100 years later, somebody goes and digs it up. And there's two reasons why I say 100 years. So first of all, nobody who had anything to do with that data is around anymore. They're all dead. And 100 years is not a random number. My understanding is that within the European Union, there are some bank regulations that require banks to actually retain some data for 100 years minimum. So, okay, so let's kind of skip the consideration that whether we're still able to read a USB stick and whether we're still able to open an Excel spreadsheet. Let's say we can. What are the chances that you actually understand what this data is about and can make meaningful use of it? I think those chances are pretty low. So I think it's important that we kind of bundle semantics with data. And there are a number of other good reasons that make semantic web technologies attractive. I mean, obviously, you know, to move from completely procedural way of doing things to more declarative, and kind of pulling the semantics out of the black boxes that procedural code is today. Graph-based representation is very intuitive, so it helps. And of course, these are based on well understood technologies and infrastructure. When semantic web was first created, people said, "Oh, it's kind of a new form of the web," but it's really not that. It's not even knowledge representation for the web. It's knowledge representation using web technologies, because web technologies have these wonderful qualities that they are widely supported, they're widely adopted and deployed, and HTTP goes through firewalls. which is what we always wanted earlier when we wanted to build autonomous agents. So all this is good. So in some sense, and I'm old enough to be able to say this, that if you sort of now ignore the popular non-symbolic methods of AI, the semantic web stack really is kind of the embodiment of what we really wanted before the AI winter. That's what we wanted from the data that our AI systems could use and manipulate. So the question is, how do we get there? How do we get to this nice end state where we can move data around and semantics goes with it, and everything's good. So I think small steps. So I think the step number one is that we map a lot of data to RDF, and there's been a lot of discussion I've seen lately where people have taken all kinds of data and they've mapped them to RDF. Things like Git commit logs mapped to RDF so that you can use Sparkle to find out what's happening, which I thought was very clever.
Yeah, actually, Justin's not on the call today, but that was Justin did that. Yeah, it was very clever. Yep.
Yes. Yep. Exactly. And so this lets us start to easier have a situation where it's easier to integrate kind of various data sources and then write queries that kind of transcend all these data sources. But that's the first step. We still have a lot of data that's in kind of non-RDF models, and all the logic is in the code and all that. So the next step, of course, is that we really start in earnest using RDF and OWL as a sort of a modeling tool, because now we can start sharing not just data but also semantics. Logic might still most of it be in code, so we have to go one more step, which is this, where we have more of the logic of our applications and not even the logic of applications, but the logic as it relates to the data. We have more of that in ontologies and not in code. So to me, this is what I'd like to see happening. Okay, so I said this was an aspirational talk, and so these two trends, this is what I want. Move towards more modeling in RDF and OWL, and move from procedural to declarative in sort of broad strokes. But this is not going to happen unless, first of all, we need to teach people how to do this. We need to make it easier to use these technologies. And my third point here is that we need to stop people from wondering whether property graphs actually still would be better and they don't need RDF. Okay, so remember this picture earlier? So where does semantics actually come from? Is this question that I often get, and I think that we need a very sort of practical view of semantics, not the sort of philosophical view. So in my mind, semantics is definitions of how data behaves and how software can interpret the data, and ontologies are sort of the means of communicating that. So given this, semantics comes from kind of the relationships between data and the definitions of the data, the ontologies, and then of course also from within the relationship that exists in data. But of course today all semantics is wired in the code, and we can't examine it, we can't look at it. So the way I sort of see this is the first thing is ontologies and logic, and sort of elevate relationships within data to sort of a more first class role. I like graph representation, and all of those we have. Nothing that I've said here is actually new technology. Now, just a couple of words about ontologies. Why do we use ontologies? Why do we want to use ontologies? So one is that we want to operationalize some data, and we want to have declarative semantics for that data for that purpose. But what people often forget is that ontologies are really an excellent means for you to fully document how you understand your data. Ontologies are documentation, and that's no small thing. There's kind of different approaches to how people define and use ontologies, and this was discussed a lot in the conference last week. So some people favor ontology patterns, just like they would like software patterns. And I think they're often useful. So then we have these kind of foundational ontologies, like the basic formal ontology and things like that. And despite my attempts to understand how to use them, I honestly can't figure out how they could be useful. And this is because I come from the software engineering side into this. I want to build systems. I want to operationalize my data, and the foundational ontologies really don't do that for me. But we do need upper ontologies, sort of upper ontologies that are not foundational, because those establish concepts that we can then extend, but that also make it easier to integrate data with other people's data and lead to a situation where we can create reusable data. And so then finally, I get this question a lot. Like people ask me, does Neptune support ontologies? I'm always like, that's a really tough question, because first we have to define what that question means. I mean, yes, you can load an ontology to any RDF triple store, but that doesn't mean that tool supports ontology. So what does it really mean? I'm still kind of pondering on that. Here's what I'd like to see for RDF and OWL. So the higher level abstractions, like I already mentioned. I think better support for composite data types. Now the OneGraph project will give us this eventually. Pathfinding for Sparkle, but actually we can use other query languages for that, because we get this query language interoperability. We may, however, need the composite data types for this. And what I really would like to see in this context is that the open source community would invest more of their boundless energy in reusable vocabularies and ontologies. That would be great. Okay, so then earlier I said we should stop people from thinking that LPGs would be better, but actually we don't need to do this, because once we have OneGraph, we don't need to stop them. They can use those to their heart's content. So here's my summary. Nobody knows what semantics means, but provided that we do understand what it means, it needs to travel with data. I'm going to fix the rift, and we need this unified language for data, including making RDF and Sparkle easier for programmers. Now it's now up to you. I've had my say. So, well, it was really intended for the conference participants, but you know, you are also the audience who should think about this. Anyway.
Is this where you want the standing ovation, or?
Well,
no, this is excellent. I mean, this is I agree 100%. But maybe let's riff a little on yeah, what of all those things you suggested do we need to do? Obviously, there's a lot of education. There's a lot of other things going on. Here's one curious observation though that I've come across recently. Doug's got his hand up. I'll turn it over in a second. But this idea of data moving with the semantics moving with the data is an interesting sort of first level approximation. I completely agree with that. I hate the bucket brigade, what we call it out there. But there's an alliance up in Canada right now. I don't know if you've come across, I think it's called the Data Collaboration Alliance, that's putting forward the idea of zero copy integration. In other words, why even move the data? You know, a lot of, and everybody's so used to that bucket brigade. And we're sort of describing, well, here's a slightly better bucket brigade. But what if we hit them upside the head and say, no, just don't even copy it, just use it?
Sure. Wouldn't that be wonderful? I think that when the linked open data movement got started, there was a lot of this thinking that everybody can just open up a Sparkle endpoint and then we can just go and query other people's data. What they didn't think this completely through, I think, because there's actual cost to running a Sparkle endpoint, and people can write stupid Sparkle queries that bring a server completely to its knees. So I'd say great idea.
Yeah.
I don't know how to do it.
Right. And these guys are mostly thinking inside an enterprise, not at the linked open data scale. But let's do Doug, then Mark, then Ahmed. Doug?
Okay. Yeah, thanks. Or this is a real interesting talk. I got two questions. One is maybe more of a technical question, but could you talk a little bit about why you see RDF star as not filling in some of the gaps so far that we've got with RDF with respect to things like reification and stuff like that? That's my first question. And the second question, you touched on at the end when you were talking about, in a sense, what semantics is, how do ontologies fit in, and you came at this. You said you come from a software engineering side of things, and that's my case as well. What I find is that modeling, when you start talking to semantics to people about semantics, they immediately think of the philosophical side of things. Are we modeling the real world, or are we modeling what the data says about the real world? You seem to say we need to focus on modeling the data, but most of the ontology books out there they don't talk really about the data. It's really more trying to model the real world in a coherent way. Hence things like BFO, which really don't help you on the data side.
Right.
So what is it going to take to shift the thinking around what ontology is to focus more on the data?
Yeah, let me answer the second question first. So whether we're modeling data or we're modeling the real world, I'm a sort of a little bit cavalier about that distinction, to be honest. I'm a very pragmatic person. I want to write software. I want to build systems. And so this whole question of sort of denotation, as it shows up in the knowledge representation community. So what do your definitions denote? Honestly, I've sort of mostly ignored that question. I can have useful data that talks about real world things, and I don't lose much sleep over whether my model is a model of that data or is it a model of the actual real world. And somebody can tell me that, somebody smarter than me can educate me why I should care. But that's just my kind of candid view of this. And this, of course, I understand this may not actually answer your question, but the first question. So what do I see as the kind of the issues that still remain with RDF star as it has been imagined today? So is RDF star does it really make RDF into a property graph in the sense that you can now have edge properties? Well, yes and no, because a very typical pattern of modeling things on the LPG side is that you could have, let's say you have two vertices and you have two edges between these two vertices, and they both have exactly the same label, but they have different properties, edge properties. And this often happens. I've seen people do this all the time. But RDF is based on set-based semantics, and so an RDF triple that represents an edge between two vertices is unique in an RDF graph. So you can't have two, even if you wanted to. And so now let's take this example, and it's actually in the paper that I mentioned. So let's say we have these two people, Bob and Alice, and our model says that Bob is married to Alice, and then we want to say that that we think that they've been married since 2019, and we can even say that according to New York Times, they've been married since 2019. What happens when we now want to say, well, actually, Washington Post claims that they've been married since 2017? You can't put another edge between Bob and Alice that say they're married with sort of this different claims about where that information came from. Now, of course, we can model it differently. We can take this kind of event-based modeling approach where we say, actually, there's this event called marriage that has a starting point, and the participants in that are Bob and Alice. And that's a perfectly fine way to do that, and it's a typical way to do that in RDF models. But that's not how the property graph people do it. And so it is that we can build these models on either side, but they don't look the same. That's
Yep.
And that actually is the biggest hang-up we have in our one graph effort at the moment, deciding how we're gonna do that. The current thinking, mine and my colleagues' thinking is that these things like property graphs and RDF star and RDF, they're kind of lower dimensional projections of the one graph. And so if you start from RDF data and you go to one graph and then you round trip back, you're guaranteed to get the same graph back. But if you start from one graph and you round trip through RDF, you're not guaranteed to get the same graph back because you may lose information.
And we've got 4 more questions, and I know these guys are going to be meaty questions. So can we get on? Mark, you want to do yours?
Yeah, thank you, Ora. That was a very interesting talk. I was having a conversation with 2 of my best engineers this afternoon about how far you can abstract away from the data into your program. So we were trying to do an autonomous interoperability example using traffic lights. So you've got a set of traffic lights in the UK, have their own sequence of events and have their own colors. And in Japan, they're different. The green color in Japan, for example, is different. But they're both still traffic lights. So even though you might have 2 separate ontologies that both talk about traffic lights, somewhere in your code, you have to refer to the concept of traffic lights. And I was kind of, I don't know whether this is a question or not, or just something that's really bugging me at the moment. It's like, we don't want to use the word traffic lights to talk about them because some of them are in Japanese and some of them are in English. So where do you get that concept from of traffic lights, where there's an instance of it in the UK and an instance of it in Japan? And how can you abstract yourself away from that in the programming sense? I'm very on your side for, this software engineering, you need to be able to describe data and you need to be able to put things in your code that refer to something without trying as little as possible to hard code words like traffic lights.
Well, yeah, that's an interesting question, and it also relates to this idea that we can take things modeled in a particular context, cultural context or otherwise, and translate them to some other thing. And several years ago, I was asked to talk in a conference that was about semantics of intercultural communication. They invited me, and I said, they said they want me to give the keynote, and I said, I don't know anything about that stuff, so get someone else. But they were very insistent, so I had to think about something, and so I thought about this kind of layered approach to modeling, And if you start from the bottom, you know, some things are really simple, like units of measure and stuff like that. We can handle those. But the higher up in this in this thing you go, things get more difficult. So a coffee shop, whatever word we use in particular culture for that, a coffee shop in Finland is not the same as a cafe in France. Even though we might actually think that, hey, those are the same thing, but in fact there are nuances. And I think capturing these nuances is an interesting challenge. Now, of course, we can always try to abstract things more, but then the round tripping becomes difficult. Yeah. You know, go from one specific extension of that general concept to another, and then come back, and lo and behold, you don't have the same thing anymore. So I think that in some cases this is perfectly solvable, and of course in the practice of software, that's what we do. We abstract things. We create abstractions so that we can generalize things. But you know, I think it's also that the devil's in the details. There can be details where it gets very difficult, and I don't have any kind of great silver bullet for that.
Okay, thank you. I'm just going to just throw in one use case where this is really valuable, I think, is in mobility as a service. So if you say, I want to make a journey which is partly by taxi, partly by train, partly by scooter, you could sort of know the individual pieces of, you know what a train is, you know what a scooter is. But there's also the concept of the journey, which starts to get really quite abstract, and also where on earth is that belong?
Right.
Yeah. Let's go. Let's go.
Sorry, yeah.
Let's go to.
Yeah, sorry. Yeah.
Yep. Let's go to Ahmed.
Go ahead.
We've got Ahmed now, Juan, and I don't know. Mike Sullivan might have dropped off, but anyway, Ahmed.
Hello. First of all, fantastically, wonderful talk. Thank you so much for doing it. And two or three things sort of quickly come to mind. One is, for the example that you gave around Alice and Bob and, Washington Post versus, New York Times, etc. Why can we not use colored graphs for that? Or why can the source of that be within the context of that particular relationship definition, be a property of that arrow between Alice and Bob, so that we can say, okay, so we basically make either colored graph or probabilistic graph attachments between Alice and Bob. Well, that also then led me to the thought that, well, could you run into a situation where relationships are not decidable because somehow you end up not being able to, let's say, do PTNet analysis of the relationships, so that you could in a complex situation end up end up where there are two indirect relationships somehow that get formed through when we are talking about higher order relationships that are in that have a fight with each other. I suspect that would, the probability approach could, or colored graphs could kind of address that. And the third point that again sort of came to mind was, oh, my brain just froze. Well,
let me answer the first two first. So the colored graph. So yes, by all means, and in a property graph, you can easily do that. You attach a property to the edge that says what color it is. But like I said, in RDF, the way RDF semantics are defined at the moment, there is no great opportunity to do that, unfortunately. And okay, so therein lies the rub. The second thing I don't exactly know how to answer that, except that I of course, via ontological means, it is of course possible to at least define that that certain, let's say, certain relationships are kind of fighting against each other, saying that that certain things could be disjoint. You can only have one or the other. But how do you then work on the what's that?
How do we encode that, right? Like the ability to encode that into the capability, I suspect.
Right. So in OWL we have some capability for doing some of that, but I think that the main question really is that if this is really sort of a probabilistic thing, then we have to step outside the classical logic and start thinking in terms of like probabilistic or statistical reasoning, which is perfectly fine, but then, you know,
like it doesn't seem to so this is probably the mathematician in me, because that doesn't bother me, right? Having a relationship that now has a weight, because that can so nicely also be represented in some type of pseudo neural net type of a capability, where you can say, well, when I hit this particular neuron, it will go to this or that, depending on some probability. I mean, that just becomes very, very obscure and maybe absurd in some ways. But oh yeah, and the third, but what you just said makes a lot of sense. So thank you for that. And the third thing just popped back into my head was, why could we not apply? We're talking about sets, and this was the thing that triggered that in my head. Like, why are we talking about relationships between sets? Why not talk about relationships between categories and use a category theoretic approach to it, so that you've got because semantics are not absolute, right? Semantics are relative to the context, and sometimes you don't necessarily want to encode the context. You talked about the USB that you buried. Well, I mean, we've had some type, and whether somebody from 100 years from now will understand it. Well, the idea is, will they understand it within the semantic or the contextual, the context that you had those numbers or that Excel sheet on that USB, right? And would they even care, right? What if they just wanted to understand, what if they just wanted to understand how people thought, or what Excel looks like? So I think the context translation is what you're worried about, right? Can we, like, the fact that Excel sheet attached to, let's say, a grocery list that you had to create every day, and that had a meaning to you at that time in your life, because
right. Well, I mean, I think from the pragmatic sense, I'm just worried that the context is missing.
Yes, that's
right.
Very true.
And as for your comment about category theory, so I have some former colleagues who would now be, really rejoicing for you to bringing that up, because some people really, and there has been some work on sort of using category theory to do some of this stuff. Unfortunately, I'm not the right person to talk about that.
No, but what you're saying sounded so much like it, right?
Yes.
And so it was like a natural sort of brain jump. So thank you so much. I'll step away. I'm sure other people have lots of questions.
We got Juan and Michael Sullivan's back. So Juan.
Hey, just quick, more of a question as a comment. First of all, Ora was always brilliant about this, and I think the slide about data plus semantics moving, I think that's a killer. I think everybody could need to be able to go express that.
Maybe I'll make a bumper sticker and put it on my car.
Yeah, there you go.
Yes, this is a very important. I just came back from the Kafka Summit, 2 days here in Austin. My message to everybody is, be prepared. Real-time streaming data is going to be the next thing, and there is no semantics. It's just JSON for them. If we thought that the problem right now is just annoying and scary, this shit's gonna get so big, and the gap between who understands this and who's doing the data stuff in that world, data management is done by software developers and in Java code. It's going to be
It's-
horrible
oh.
and it's taking over the world. Pay attention to it. That's my comment.
Oh, you just
Have a
scared the
great day.
heck out of me,
Good comment.
Juan.
Yeah.
Or a lot.
Okay, Michael, you get the last shout, Michael.
Or are you familiar with the work of CJ Date?
Um,
He's one of the inventors of SQL, and he's also written a book on 6 normal form. Are you
yeah,
familiar?
I mean, that vaguely rings a bell, but not in any kind of detail.
You might want to take a look at 6 normal form because both property graphs and semantic graphs can be represented losslessly as 6 normal form.
Yeah, and I know that there's been other work on this sort of these kind of higher level meta models that can capture a lot of things. Work I've seen in the past has been interesting, but has had the problem is that the models become hard to understand. So, but that may be kind of a naive understanding of what's going on there.
Just a quick thing on that. That's what relational AI is doing. I know you guys talked to Mollen before, but 6 normal form is just representing unary predicates and binary predicates. So it is just basically doing RDF inside of a relational model.
Well,
6 normal form when you start analyzing.
And it aligns with the vision of being able to use SQL or property graph or semantics on the same data store.
But you are frankly just representing triples and relational matter in the most
That's right.
granular piece.
Each predicate is represented as a table. That's right.
Yeah. So
Okay, maybe I'll get the last shot. I have two questions. One, so is one graph going to become open standard, or is it going to be proprietary?
We would like to make it the specification publicly available. We're not going to do that yet because it's kind of half-baked at the moment.
Yep.
And we'd actually like to. We don't want to be terribly embarrassed when we publish it. But eventually, yes, we don't want to keep this to ourselves. We see this as something that benefits the entire industry and community.
Yeah. And the other thing, I just want to put a plug out there for GIST to be your one unifying ontology. I think actually it addresses Mark's thing. GIST as it is, you don't even have to extend it. The traffic light is an artifact. It participates in a system. That's one of the classes in GIST. It's in a network, which is a communication network and also a traffic control network, and would have a handful of behaviors, which just is exactly what you were saying earlier, Aura, that, semantics is about describing behavior. And in this case, behavior is permission to drive and telling you not to drive. And then it's only at the very leaf that you say in England it's green and in Japan it's blue or whatever color it is.
In China,
so the whole structure should be identical. What's that?
In China during the Cultural Revolution, I understand red meant go.
Yeah, so that's just on the leaves, the whole structure, they all have lights and communication, electricity and traffic and behavior that's permitted and not permitted. And yep.
Oh, also,
Cool.
Dave,
Thank you, Dave. That's actually very useful.
just a real quick one. I've convinced one of the product groups in Oracle to adopt GIST. So we should.
Yeah, I heard that. Excellent. Thank you, Michael.
Yep.
Very good. This was excellent, Aura. Thank you. We're all on board. We just got to figure out what to do next.
Thank you for inviting me.
You bet. Take care.
Good night, everyone.
Take